All right, everyone. I just want to quickly introduce what Advanced Hardwood Biofuels Northwest is for anyone who may not be familiar with the project. It's a USDA National Institute of Food and Agriculture funded project. It's one of the CAP grants in the US. And the project is looking at how you could grow hybrid poplar as a short rotation, essentially as an ag crop, and use that biomass to create transportation fuels, bio-based chemicals, and other useful products. It's a consortium of university and industry partners that are conducting the research and the education and outreach. It's led by University of Washington. And we are now in our 6th year of the project. Today we'll be hearing from Jesus Espinoza and Brian Stanton, who work for GreenWood Resources, which is the timber management, the tree growing side of the project, if you will. And they'll be telling us what the research team has determined in terms of the yields that we get from hybrid poplar and the various varieties. So looking at the poll questions on the right, it looks like we have academic researchers, some AHB partners, extension personnel, and business and industry. And it seems like most people are getting our emails. Excellent. If you want to watch this webinar again later, it is archived on our website. It'll be up probably later this week or early next week on our website, hardwoodbiofuels.org. If you have questions as the webinar is going along, please type them into the chat box. And I just had a comment that someone cannot hear me. Can I get confirmation from someone if they are able to hear me? To make sure I'm not talking to myself this morning. All right, Bernie can hear me. And Kat and Patricia, all right. So we seem to have temporarily lost our speakers, so we're going to give them a second to come back. Technical difficulties is always part of our morning, it seems, whenever we do these webinars, so please hang tight. All right, Jesus, can you hear me?
I can hear you now.
I can hear you.
Ah, perfect. All right, then I'm actually going to pass it over to you and switch over to your presentation slides and let you take it from here. So again, if you have questions as the webinar is going along, please type them into the chat box, and at the end we'll go through the questions. And if you have any technical difficulties, let me know that way as well. So thank you, and here is Jesus Espinoza and Brian Stanton from GreenWood Resources.
Thank you very much. Good morning, everyone. I would like to start with this presentation with to say thank you to Noelle and Patricia from Washington State University extension team of the AHB project. Thank you for this opportunity for organize this webinar and let us to show the audience what we are doing to quantify the growth and yield of the hybrid poplar bioenergy farms that we are managing since 2012. We are going to present to show you in this presentation the location where the farms are located, as well the climatic condition of each of the site, agronomic practices, the row layout for the planting, harvesting schedule, the inventory procedure, how we quantify, we collect the information and quantify growth and yields. Also, to present the result from the 2017 inventory, the last inventory in the second cycle of copies and management. With that, this slide that you see here is the location of the hybrid poplar demonstration farms. This project has 4 farms, demonstration farms. One is located in Pilchuck in Washington State. It's north of Seattle. We have another farm in Hayden, Idaho. one farm in Jefferson in Oregon, and one farm in Clarksburg, California. So that is the fourth operational demonstration farm that we have in this project. And also, I would like to emphasize here that we are participating as well with the IBES project. This in the Southeast is a partner, and we are managing this demonstration farm where it's located in Columbus, Mississippi. In this slide, we are showing the climatic conditions and physiographic factors of the different demonstration farms where they are located. As you can see, it's a significant contrast between the size or among the size. We have different precipitation regime as well as elevations of the different farm. We are moving from sea level in Clarksburg, California to 2,300 feet in Hayden, Idaho. The same trend is in the physiographic location, different location and soil types as well, from clay to clay loams and core gravel fractions as well, and the topography change from one side to the other, from the flat line on the rolling hill to more or less 10% of slopes in Pilchuck, Washington. Um, I would like to talk at this moment regarding with what agronomic practices we have been working since we established the plantations of the in each of the demonstration farm. We did the site selection based on the parameters that I showed you in the slide before, even including other factors as refinery location, transportations, accessibility at the site, in each of the site, etc. The population around of the farms. So once we select the site, um, we start the site preparation. The site preparation was very simple, trying to minimize the impact in the to the soil, and we just improve based on chemical and mechanical weed control, pre-plantation and post emergent as well, pre-emergent and post-emergent. We did the tisking and subsoiling to improve the root accessibility. Um, we also use different planting density. We start um, with trials. We establish at the same location where the operational plantation are located. We established as well several trials. One of them was to determine what is the appropriate stand density. We established a biomass trial with three different stand density: 1090, 1452, and 2,178 per acres. However, the operational blocks are planted at 1,452. That is 30 square feet spacing. Um, we use for planting or as a root material macro cuttings 10-inch long and 0.6-inch in diameter, all dormant cuttings. Um, we established, as I mentioned before, biomass trial to quantify the biomass, but also to evaluate where is the how we can manage the coppice regeneration. We have two treatments: dormant season, coppice during the dormant season, but also the other treatment was coppices, the trees during the active season. So we have the opportunity to evaluate if we have one season better than other to do the coppice, or we can coppice through the entire year. That's mean harvesting during the entire year. Um, Regarding with the crop care, It was simple, just chemical and mechanical weed control when needed, and also we did a monitoring of pest, disease and insect control when it's needed. We just work with that to control or keep the population in control to avoid any damage to the plantation. Um, this is the row layout as a how was planted or each of the blocks. You can see on this line, um, we are just trying to show is the planting line, simulating the planting line, and you can see that the distance or the spacing between the distance from the center to the center of each planting line is 10 feet, and the distance between trees on the planting line is 3 feet. That means is the spacing is 30 square feet per trees. Um, each line was ripped, as I mentioned before, and planted with these cuttings, as I mentioned at the beginning. This is a picture just to illustrate, you can see on the here is the tube planting road, because the plantation was in zigzag, so on the same planting it was as with some angle one tree for the other just to improve the harvesting process. Um, as you can see here, this is the two um, planting road that represent these two lines here. This picture that I'm showing here is just the plantation like a 3-4 months old after coppice, the first coppice in Jefferson, and the picture below is the harvesting that we are doing in at this moment in Jefferson. So it's the same picture. You can see the tube planting line that represent the line in this graph. And this slide is the map of Jefferson Demonstrations Farm. You can see here that we use around 11 different clones to evaluate what is the best clone adapted to this kind of environment condition, the best growth performance. From these 11 clones, you will see the result. Each of the clonal monoclonal block was evaluated independently. So we had data from each of these monoclonal blocks. As you can see, we have also the research area. In this research area, we established several trials, genetic trials, where we are testing around 75 different clones to evaluate the level of adaptability, the growth performance, but also the biomass quality that can be obtained from each of them. The information has been recorded and analyzed in different labs to verify the results. This map corresponds to Hayden Demonstration Farm, located in Idaho, and with the same approach that we use in Jefferson. Uh, each we use here less number of clone, different clone because it's different environmental condition, different type of soil and elevation of the site. So we use different clone to evaluate their performance as well as a monoclonal blocks, and we evaluate each block independently. We had the research area as well. Here in this site, we are testing other 75 different clones. So the idea is from that trial we can get information what are the clones that grow better or has better adaptation to that kind of environmental condition that characterize hidden demonstration or in Idaho in this case. We have reserve area. We have also the intercrop. We have a plantation that where we plant um, poplar, and then in the middle of the trees or the poplar trees we plant alder. And the reason that we use alder is because they have the characteristic or the property to fix nitrogen, and we want to know if that species can help to fix nitrogen that can be used for the poplar trees to grow and improve growth performance. So that's we also another kind of evaluation of the test that we established there. And this slide is, as I said at the beginning, it's just to demonstrate, to show you the harvest schedule for this project. We established, as I mentioned before, Jefferson and Hayden in 2012. Clarksburg and Pilchock demonstration farm were established in 2013. So the first harvesting from planting single stem was made in 2013, and Jefferson and Hayden, when they say 2 year growth, year is 2 year growth, two growing season. The growing season of 2012 plus the growing season of 2013. So we harvest Jefferson and Hayden on fall of 2013 after the finishing the growing season. And the plan is three growing season or after we copies them. So we have been managing for three consecutive growing season the plantation on the multiple stem copies that mean, and we are at this moment harvesting Jefferson, and we are going to move once we finish Jefferson to Hayden. So 3 years copies a cycle, and we once we harvest these two sites we will start the restoration. In Clarksburg and Pitcho that were planted in 2013, so we harvest at the end of 2014, giving us um, two growing season as well. So the objective now is that we will harvest Clarksburg and Pilchock and at the end of the 2017 when they finish the three growing season. Even though that we will restore because it's at the end of the growing the year, we maybe will do the site restoration in 2018. But we are evaluating that as well because in Clarksburg the trees are growing very well, and maybe we will need to harvest before because the capacity of the single pass harvester that we are using maybe is will not capable to harvest this kind of tree with this big growth. But we are doing the evaluation at this moment to take the final decision. Now I'm moving to be more specific regarding with the inventory procedure. Um, so here is the schedule, how we has been working to evaluate or to quantify the biomass that are producing from each of these demonstration farms located in the four locations. In Jefferson, in Hayden, that were established in 2012, at the end of the year, we did the just qualitative assessment. That means we quantify, we take the height, but this was just only to get the survival. How good was the establishment of the plantation? So at the end of 2013, two growing season, we did the pre-harvesting inventory. We did evaluation, we measured diameter, we measured height, and based on that information, we determined volume growth and yield. We did the copies after 2000 at the end of 2013, and then we did the inventory from copies in the winter to 2014, 2015, the first year of growing, and the second growing season, 15 and 16, and then we did the last inventory pre-harvesting that was made in the past winter, 2016 to the 17. The same approach we are doing with Clarksburg and Pilchuck. Nevertheless, as I mentioned before, in this spring, we took some samples, subsamples, or a sub-evaluation for Clarksburg and Pilchuck to determine if the tree are growing so fast and the harvester be capable to do the process. I mean, the harvester can harvest this kind the trees. Once we do the analysis, we will decide if we can wait until the end of the year to do the harvesting after the third growing season, or if we need to do the harvesting when just after the second growing season. So what we do in the inventory, we established a permanent plot when we did the first evaluation of survival and the second and the first cycle from planting. When we established this plot, inventory plot, we established we put some monument on each of that plot, and we took the coordinate of this point. So that's mean that we establish that plot as a permanent plot, and every year we go to the same plot to do the assessment, do evaluation, so we can keep tracking how the performance of those trees on that block in each year, even after copies. So that is what we say, or what we call permanent plot. In addition to the assessment or the evaluation of the diameter and height, once we get all this data, we select 30 trees and do the structure sampling. We cut 30 trees, getting representation of the entire diameter distribution based on the results from the inventory. And then in this 33 that we cut is for each monoclonal block. That means it's a clone by clone basis. We did that in Jefferson. We did that as well in Hayden, and as well for the other two sites. So now I will be focused more in Jefferson and Hayden, is because that is the two sites they are now finishing the third cycle that is our target in this project. The other two sites will be finishing at the end of the year. So once we select that 33 that I mentioned before, we cut them, do the structure sample, and then we collect sample and send to the lab. That you will see in a few minutes how is the process. When we finish the inventory, usually we do the inventory using contractors. So we have to audit that work to verify that the results from the inventory are accurate. So we do is that we going to the field and select about the 10% of the entire plot and do the evaluation to check if the height and diameter corresponds with the information that was collected by the contractor. So we check the measurement, and the measurement that we take or we are verifying must not differ by more than 20% for height and 10% for diameter. It's just to check and verify that we feel confident with the information that was collected. So in this slide that I'm showing here is just an example, and that corresponds to Jefferson. Each point that you see in the map corresponds to one permanent plot. And each this permanent plot have their own coordinate, as you can see here, and on the right side. This is plot 1, 2, 3 for each monoclonal blocks. So we have the latitude, the longitude, where they are located for each of them. So we can come back every year. That's the way that we have been doing every year to collect data and evaluate the growth performance of the plantation. You can see there is each of the monoclonal block, different clones, and this is for Hayden. A similar procedure. Each point corresponds to one permanent plot, and on the table below, on the right side of your screen, is the coordinate of each of the plots. So we can go in there and verify the information and come back every year to do the evaluation and keep tracking how is the growth performance by clone and peer plot as well. And we can catch the site variability as well, because we are tracking the plot and trying to represent all the plots across the entire block. So in this slide, I will just want to emphasize how is look a plot. In the plot, we have 12 trees, as you can see on the right side, and we measured the 12 trees, and but also we see the monument that we established at the beginning of the plantation. This is the monument that we verify every year to determine what is the tree number 1 and what is the tree number 12. So we have well identified them, and also we measure the size of each of the plots, because even though we try to be the more accurate possible with 30 square feet, there are some differences, and we catch the difference measurement each of the plots to determine the stock per acre. So what is the data that we collect from each of those plots that I showed you before? We collect DBH or each stem. Is it from planting? Of course, it's just one stem. And it says copies that we have multiple sprouts. And for each, in the case of the copices, we measure each of the stool that has more than 40 millimeters of DBH or larger. But that is in case of 3-year copices. If it says 2-year copies or 1-year copies, the 40 millimeters is changed to 25. All depend how is the age or what growing season we are evaluating in this case. If the sprout fork below 15 decimeter and both are larger than 40 millimeter and DBH for the case of tree growing season, we measure this as a 2 stems. And then if the sprout forks above the 15 decimeter and is larger than 40 millimeter, in the case of the third growing season, we measure this as just one sprout. Other information that we collect, we measure and record the total height of the tallest stem, just to have the references of the site quality, and we measure as well the plot dimensions of each plot to determine the proper stocking, as I mentioned before. Here I'm showing just what is the type of data collection. This is for just one plot. In this case, it's a clone 63220. We have the plot number, the tree number. You can see from 1 to 12. We have the GPS coordinate. We have DBH1, DBH2, is stem 1, stem 2, all depend how many stems in the stool has, and until DBH4 or 5, 6, depending on how many sprouts we have there. We count the number of stems as well, and the length of the plot. To determine the size of the plot. You see length width 1, width 2 is in each of the extreme of the plot, since this is a rectangular plot, or trying to be a rectangular plot. And you see in the bottom of this table the average of the diameter for this plot, what is the minimum diameter, and what is the maximum diameter found in this plot. This is an spreadsheet in Excel that one of our colleagues developed to keep the inventory and take the decision in the field what kind of tree we will cut it to do the destructive sample evaluation. Here is this table below show the selected 33 for the destructive sample. You can see this is the diameter, so we collect trees from the diameter according to the diameter distribution that we found for the entire block. So we're trying to get representation from all the dimensions or all the diameters found on the monoclonal block. Here in this table, on the upper right side, is the clone, the 30 clone, and what kind of information we take from these 33 that we cut. We take DBH, diameter in the base, total height, and we weigh them. The total weight per each stem. In this case, this trees is a single stem, but if it is a stool with multiple stems, then we have a stool 1, stem 2, stem 3, and so on, depending on how many sprouts we have on the stool. Using this data, and then we develop the regression equation or the model to determine the total biomass or the yield from the inventory. This from the 33 is the sampling that we use, is the data that we use to project, to predict what is the yield for each of the clones. So we do that at the clone level, but also across clone. By side as well. So you can see 4 different equations for Hayden and Jefferson. And the first equation is just using DBH. The second equation, we are using DBH squared. And the third equation that we are using DBH and DBH squared as well. The fourth equation is trying to develop using basal area. The same methodology was used for Jefferson, and you can see the R squared is very high, over 93, 94. So it's very good and strong, since we are taking significant amount of data to build this equation. And each year we update the equation based on the new data that we are gathering from the inventory and the destructive samples. In this slide, it's showing several pictures just to show you how we proceed with the destructive sample in the data collection. We cut the trees, we lay down, and then it is in the growing season, and they have leaf. In order to determine the partitioning of the biomass above ground, we wait, we leave, and then we remove the leaf from all these branches and wait again. So we had a proportion of the leaf in each stem and by a stool as well. And then we cut them and weight each of the stem and add for the stool level. We take good sample from the top and the middle and the bottom of the stem and sent to the lab to determine bark content, moisture content, and a specific gravity as well. And we weigh that information, that numbers. In the picture, you can see we weigh branches to determine how much branches, what is the proportion of branches on the stem, and but also at the stool level. We weigh all of them. Here is what we get the information. We collect the samples from each of the stool or stem that we got it doing the structure samples. We send to the lab. We determine bark content, moisture content, and a specific gravity for each of the samples that we collect. And the table on the right is just to show you all this the information that we collect from the lab and the calculation we do in order to determine each of these proportion and bar content, moisture content, and specific gravity that we use also and add to the equation that we developed in the model to determine the total biomass and the yield that we estimate from each of the monoclonal blocks. So as I mentioned before, the idea of weight all of them in a separator is just to see what is the biomass partitioning. And the information that I'm showing in this slide is for a single stem. So based on the results that we had collected during this project, in a single stem level, we have about 20% of leaf. Of the total biomass, 20% correspond to the leaf. And we see and the other 80% is distributed by among bark, branches, and stem. Taken and this proportion, the 80%, 18% more or less is bark, branches is about 32%, and stem is around 50%. So that's more or less the proportion that we found so far. Now we are doing the similar work with the coppice management at different age. First growing season, second growing season, and third growing season. How that biomass partitioning change from one growing season to the other growing season. In this picture, is just to show you how two growing season, two growing season plantation after coppice look like. This is Jefferson. You can see on inside the plantation is really like a 2-3 stems per stool. The other stem or sprouts that were in the stool are suppressed by the big stem. So at the end we are collecting or we will harvesting 2 or 3 stems in average. But that is how they look like. It's a really good growth on Jefferson. This is another picture. You can see different clone, different dynamic at the clonal level, multiple stem but smaller, or the diameter are smaller, and the proportion of the leaf is changing as well at the clonal level. You can see here two different clones, different bark, different diameter, and different branch size as well. So it's a really good growth that we can see in two growing season after coppice. So now I'm going to present the results that we found from 2-year growing season from planting. That means single stem. Planted in 2013, the first growing season and the second growing season after from planting. So here is Jefferson and Hayden, planted in 2012, harvested and 2013. And you can see the different clones and the different performance. I mean, the level of adaptability, the good quality change as well, and the efficiency at the clonal level change. This is for Jefferson, and you can see as well for Hayden. Clone and Jefferson are performing better than in Hayden in some cases, but in other cases, clone like 12A04 growing better than clone 4491 in Jefferson, for example. This is for 2 growing season from planting. Now I'm going to show you the results from 3-year growing season after coppice. So that means multiple stem, as the picture that I showed you a few minutes ago. Here is the good information that we had data from the first growing season after coppice, second growing season after coppice, and third growing season after coppice. So we can build this kind of curve that I'm presenting in this slide. You can see different clone, different performance, different level of growth. Some clone grow very well the first growing season and then slow down, and as you can see, all of the clone is a common factor that in the second growing season, the growth declined a little bit, and this was because the severe drought season in Jefferson, so in 2015, and that has impact the growth. But you can see when the environment condition change, the moisture content change, water availability, they start growing as again. So what we could do in this case is that if we are going to plant or recommend a new plantation in this kind of environment, we can select the best 4 or 5 clones that has really good performance, and we are more accurate with the type, the species site matching. This is for Jefferson, and this is for Hayden. You can see it's less number of clones, but as well, there are some clones that perform very well and they keep growing. He, here, here we have one thing is completely different than Jefferson. In Jefferson in GR2 in the second growing season, as I mentioned before, it was very drought season. So it does impact the growth performance of those all of the clone. Here you don't see this kind of the decline in growth. It's just because this site is completely irrigated during the growing season. So it's no limitation in water in this case, and for this reason the clone keep growing. But after the second growing season, the third growing season, even though they keep growing, the slope of the curve decline, and the reason is because they are competing each other. It is the crown is competing at this level, and for this reason we project that the third growing season we should cut the trees, other way the growth will decline. And we can select again the first 4 beds of 5 clones that can be planted in this kind of environment condition, and we have high probability that success regarding with the projection of the growth that we will see in a future slide. So in this table, we are summarizing the yield in bone dry ton per acre. The first column here is correspond to this the yield found on the 2 growing season from planting, single stem for all the clones in both sides, Jefferson and Hayden, and we had the average for the site. You can see here that the site and Jefferson side is giving better resources, or the clone in that side are performing better than the Hayden. Even though in Hayden we have really good growers as well. But from planting, two growing season, single stem, that's the growth performance or the yield. We can see in the second column here that I'm showing, the third column, pardon me, two growing season. One is from planting, the other one is after coppices. So the after coppices have multiple stems, and you can see the yield change uh, significantly is higher in after coppices, and that's what we are expecting because we have multiple stems. And that is why we are managing coppices, why we are recommending to manage the biomass plantation with coppices. We can see the performance. And in the last column, we see the projection of the growth of the yield for the third growing season that is increasing from 10.3 in the second growing to 24 on the third growing season. That means it's growing per year in average like 8 bone dry ton per acre. So it's a really good growth and performance. Of course, there are some clones that the performance is more, I mean, is poor. Uh, and we can say that it's about 11 in Jefferson and 9.6 or 10 in Hayden. But an average for each of the side is really good growth performance for 3 year growing season plantations. So in this table, I'm showing this table just to show you or to let you know that we're doing some search on the publication as well, what people have found on on the different trial that the people has been established across the country and in other part of the world. And you can see on the table on the right where the pointer is, this is for 5 growing season, plantation for 5 growing season, the yield. And this in these 5 different sites, we can see um, that the growth or the yield for each side in average 3.8, 6.2, 5.5. The best one is 17.9, but that's in 5 years. We are getting 24 and 3 growing season. This is 5 growing season and 2 growing season less, and we are reaching 24. That is about 50% more. That is Michigan and 6 different sites. Um, that is also colder than here as well, so that can be affecting. But the important point here is we just want to emphasize that the plant, even though there are some difficult seasons here with very drought, with the results that we are showing here are very promising for the biomass production. And likewise, I mean, on the table on the left is more a single stem and age 5, 6, and 7 for different purposes. But the yield that we are obtaining in our plantation or in this demonstration farm are very, very good comparing with those results. Uh, at the same time that we use um, the inventory, we determine leaf area. Leaf area is ecophysiology parameter that has been using to determine how good the plantation are growing. Is there any limiting factor affecting the growth performance? So we determine leaf area from indirect way using the LICO 2200C. Um, the two ones, one ones is as you can see on the upper right, that is in a clear space, simulating above the crown, measurement above the crown, and then on the left, two less picture on the top it is just taking measurement below ground. So by the difference, we can determine indirectly how much leaf area the plantation has, and based on that measurement, we can determine leaf area index. The picture below it just show how we can manipulate the information that we are gathering from this uh, leaf area measurement with the light course, and we can see on the less below on the left side, the bottom left side, is each point that we measure for each monoclonal block. The picture in the middle is the profile for each monoclonal block from the horizontal view. And the picture on the bottom on the right side, you can see the each monoclonal block, and we have, unfortunately, we can show very well here the average of the leaf area, but this is a bar there that's showing the average of the leaf area index for this monoclonal block. So using this data, we can estimate the correlation between leaf area index and yield. And highlighted the Jefferson and Hayden because it's the third growing season, and you can see the mean leaf area for this side is 5 and Hayden 4.6, very similar, and Jefferson had better growth than Hayden. Does it correspond? And the R square for each of the side is really good. Even we haven't get the total yield from the harvesting, but just from the prediction, it's really, really good. And the overall for the foresight, the R square that we found is 0.82, which is very, very good. So we can predict when this plantation can need a fertilizer or no fertilizer, or there are something that happening or limiting the potential growth of the hybrid that was planted. So that's a very useful tool as well that we are using to predict and to improve our silviculture management of the plantations. With this picture that I'm showing here, is just to illustrate how different are the, are the clones. Each clone has different physiology and different efficiency as well. And as you can see from the left to the right, each monoclonal block had different um, performance. So some of the clones have already dropped all the leaf, others are still very green, and the others are in the process of senescence. So it's extremely important that that's kind of the take into account that each clone has different performance, different requirement, different physiology. In conclusion, we can say so far that the coppice regeneration plantation can reach biomass yields around 3 times more than 2-year yield from a single stem. That means from planting, single stem plantation. The yield obtained from the coppice regeneration system using the top 4 clones fit within the range that originally was projected. That was between 8 and 9, 7 to 9, and we are on this target using the best clone. The yield vary among the top 4 varieties, Jefferson and Hayden from 18 to 24 in Jefferson, and from 16 to 21 in Hayden, what is a really good growth performance or yield performance. The growth and yield that data generated during the HHB project, I will say, is the strongest data of hybrid poplar plantation at the operational level for biomass production that exists in North America, or at least it's one of the best. We are testing here about 300 plus acres with different clone, different site condition, different management, and that has been very successful. We can say with very uh, strong um, confident. And with that, I would like to say thank you very much to all of you to be in this webinar. And I guess we have some times to respond any question if you have it. Thank you very much to all of you.
Thank you so much, Jesus. Clearly, GreenWood has been working very hard, yourself included, collecting all sorts of wonderful data on how you would grow poplar trees and how much biomass you can actually get from them. It looks like Bernie is typing in. If you have questions, please type them into the window and I will read them out and then pass it on to Jesus to answer. So Bernie asks what the difference is between dormant harvest versus in-season harvest, and it says reduction over time on coppice suspected. Jesus, did you want to address that question?
Sure. Thanks, Bernie, for the question. Um, Regarding with the different and dormant season, harvesting, and the active season, or it's just because the leaf content. Leaf content is a big issue for the refinery. So it is extremely important what we found during this 5 years of experience with this multidisciplinary team that actually conform. So we have the refinery. We supply some samples to the labs, and definitely they don't want biomass with leaf because ash content and other many factors that imply um, when they are using biomass with leaf. So for this reason, a dormant season is the most appropriate. At least we can find a methodology or a procedure or harvester that can remove the leaf during the harvesting process and 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 can do the harvesting to the entire year. But that's the why. And the reduction over time copies, based on the density that we are using. Um, we are using 1,450 trees per acre. Third year, they are really competing each other for spacing. So the density that we are using 3 year could be the maximum age to copies at again. And the idea is cycle for five different through five different cycle copies the leg grow, three more growing season, copies it again for 5 times. That is our target, and we believe that is the result that we are finding or confirming during this project.
Thank you, Jesus. And if everyone could also fill out the poll questions on the right when you get a chance. I had a question. So if a landowner was trying to assess, they were growing poplar trees and they wanted to assess what biomass is out there, is it easier for them or cheaper for them to assess it using leaf area index and using your model there, or would it be better for them to do some destructive sampling or plot sampling? Do you have an idea of what would be better for a landowner?
Um, I do believe both way work, but remember, the structure sample is the information, the accurate information that we can get, the most accurate information. Leaf area is index is indirect measurement, and that is giving us an idea if we need to. I mean, if the leaf area index is below, let's say 3, then we something is limiting the growth there, and we need to act through silviculture management. Maybe more weed control, reduce the weed competition because the we are growing so much, or maybe we need to add some fertilizers, some nutrient because the soil cannot supply that kind of resources to the tree that is needed to keep growing and this kind of evaluation. So it all depend the situation, but remember, if we are going to quantify the yield, the structure sample is of course the way to proceed to develop really good equation adapted to the specific conditions um, for 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 that specific site. So uh, all the people can use general equations that work as well. So all depend on what kind of level accurate the information the landowner wants.
Thank you, Jesus. That makes sense. Do you see the
Yeah,
question there? I can let you answer that.
yeah. Of course, the idea for us is to keep moving and keep maintain the site for other or three more cycles. Unfortunately, we are looking for more funding to see we can keep the site work moving on. But so far we haven't, and we are working on that direction. We would like to at least keep one or two sites until maybe two, three more rotation.
All right, thank you, everyone. Are there any more questions to be typed into the chat box?
Um, I would like just to say thank you very much to all of you, but at the same time to inform that this result that I'm showing here is not just my work. It's the work of the entire team. It's a lot of people behind working very hard and make this project possible. And we really are very pleased with the level of commitment that people has been showing in this project. Engagement from the different team as the extension team, and the other teams including, of course, Feed the team. It's a really nice project, AHB. I really very pleased with this level of commitment. Thank you very much to everyone.
All right, with that, I think we will end it here, and thank you, Jesus, again. And yes, HB is a very large project, and it's been very successful in its collaboration. And GreenWood Resources has been absolutely fantastic, not just on collecting the data on the yield and growth and harvest, but also in terms of outreach, in terms of communicating with everyone on the project. We very much appreciate the effort that GreenWood Resources has been putting into advanced hardwood biofuels. So with that,
Thank,
have a good day, everyone, and thank you for joining us.
thank you.